Next one we have testing of surge diverters. So in modern practice, surge arresters or lightning arresters are the most reliable operators to protect in the power system against transient voltages due to lightning and the switching surges. They are used from a low voltage of around 400 volts to highest system transmission voltage like above 765 as well. So hence the preci- testing in a precision way and to make it standardization in the laboratory with the standard test procedure are of the great importance in the modern power system engineering. So hence the surge arresters has to be a non-conductor for operating of power frequency voltages. It should behave as a short circuit for transient over voltages of impulse characteristics, discharges the heavy current and recovers its insulation without allowing the follow-up of the power frequency current. So there are the different current ratings of the surge diverters that you can see to that. So we are looking for what are the tests can be conducted for the surge diverters. So there are the different tests like power frequency spark core test, 100% standard impulse spark core test. We have residual voltage test, then high current impulse test. In that we have for longer duration of the current pulses, then operating duty cycle test and other test. So these are different tests which you're going to do it on the surge diverters. So coming to the first one, that is the power frequency spark over test. So this is the routine test. So this is conducted using a series resistance to limit the current in the case of there is a spark over occurs. It has to withstand 1.5 times of the rated value of the voltage of 5 successful applications. So this can be tested under both the dry and the wet conditions. Then next we have 100% standard impulse spark over test. So this is conducted to ensure that the diverters, the surge diverters operates positively when over voltage or impulse nature occurs. So the impulse generator is adjusted to give standard impulse voltage of the present magnitude which is specified in the specification. The arrestor has to spark over every time in each of the 10 successive applications. So then the test is done with both positive and the negative polarity of the waveforms. So sometimes the test is done by starting at a voltage level that does not give any flashover at all and repeat it in increasing steps of the voltage till there is an 100% flashover occurs in the required spark core voltage. Then we have residual voltage test. So this is conducted on prorated diverters of the rating in the range from 3 to 12 kV only. So the voltage developed across non-linear resistor, that is nothing but NLR, during the flow of the surge current through the arrestor is called as residual voltage. So the voltage developed across non-linear resistor unit during the flow of surge currents through the arrestors is called as residual voltage. So the standard impulse waveform of 1 bar 50 microsecond is applied and also it is recorded. and also this can be recorded by using the CRO. The magnitude of the current or approximately is of 0.51 and 2 times of the rated currents. So generally it is of zero point 0.5. It's not only 2 times of the X rating, 0.51 and 2 times of the rated current. So from this, that's nothing but the oscillogram. A graph is drawn between the current magnitude and voltage across a prorated unit, and the residual voltage is also calculated. So from this graph, the residual voltage corresponding to exact rated current is obtained. So these are the some of the nomenclature which we are going to visit. V1 is nothing but the rating of the complete unit. V2 is the rating of the prorated unit test. VR1 is the residual voltage of the complete unit. This is voltage of the prorated unit. It is assumed that V1 by V2 is equal to VR1 by VR2. So let we are considering that Vrm is the maximum permissible residual voltage of the unit. So then the multiplying factor, that is nothing but R, is defined as multiplying factor of the rating for the residual voltage, so which is mainly depending upon the value of the V1, and the diverter is said to be passed when VR2 is less than R into V2. Next one we have high current impulse test on surge diverters. This is done on prorated arresters in the range of 3 to 12 kV. A high current impulse wave of 4 bar 10 microsecond peak value, which is mentioned in the specification, is applied to a spare unit of identical castings. This test is repeated for 2 times. That is nothing but 2 such applications are made on the units under this test, which is allows a sufficient time for the cooling of the unit to the room temperature. The unit then it is said to be in pass the test if the power frequency spark or voltage before and after the test does not differ by more than 10%. Then the voltage and the current waveform of the diode do not differ in the two applications, and the nonlinear resistance element do not show any puncture of the flashover. So in that first one, long duration impulse current test. This test is also done on prorated units, same thing, that's a 3 to 12 kV. The circuit used for generating a rectangular impulse pulses wave consisting of an artificial transmission line with a lumped inductance and the capacitance, that we know that the duration which we know, that is 2 in bracket n minus 1 multiplied by a root of LC. So as per the specification, the 20 applications are made with the specified current in 5 groups. So that the interval between successive application is about 1 minute. It is usual to record a waveform in the first two and the last two applications of the current wave. Then the diode is said to be have passed the test if the power frequency, spark or voltage before and after the application of the current wave should not differ by the 10%. The voltage across the diverters at the first and the last application does not differ by 8%, and there is no sign of the puncture or the damage after applying these the current pulses. Then we say that it is passed. Then we have operating duty cycle test. So this is conducted on the units of arresters and gives better closeness to the actual conditions. So the arrestor is kept energized at its rated power frequency supply voltage. The impulse current waveform, which is applied first at a phase angle of around 30 degree from the AC voltage 0. So if the power frequency follow on current is not established, the angle which the current wave is applied is advanced in steps by at an angle of 10 degree up to 90 degree, or the peak position of the supply voltage wave till the follow on the current which is going to establish. So in the course of the application of the current wave, if the power voltage, that's nothing but power frequency voltage, is reduced during the flow of the current, it can be compensated up to maximum value of 10% of the over voltage. So the time interval between the each application is of about 1 minute, and between successive groups it is about half an hour. The arresters is said to have passed the test if the average power frequency spark or voltage before and after test does not differ by more than 10%. The residual voltage at the rated current does not vary more than 10%. The fall on the power frequency current is interrupted HE time, and there is no significant change in the signs of the flashover or the puncture occurs to the rated unit. Then we say that it is passed the test. Other than this, we have other tests, that is mechanical test like porosity test, temperature cycle test, then we have pressure life test, then voltage withstand test on the insulator housing, then we have switching surge flashover test, then the pollution test. So these tests are usually done on diverters which is used in EHV system. Next concept is radio interference measurement. In many electrical operators like transformers, line conductors, rotating machines will produce an unwanted electrical signals in the radio, and high frequency devices like television band, microwaves, etc. So these signals will arise due to corona discharge in the air, internal or partial discharges in the insulation, sparking at the commutators and the brush gear in the rotating machines, etc. So that's why it is an important see to that the noise voltage generated in the radio and other transmission bands are limited to acceptable levels, and hence radio interference voltage measurement is plays an important role. So it has been found that surface conditions of the overhead conductors is subjected to high voltage stress, and varying atmospheric conditions will influence the magnitude of the noise voltage which is produced. So in the case of the solid insulators, the bonding between porcelain and the metal pin, the binding of the high voltage conductor and the insulator surface, and the surface pollutions were found to be the source for the noise. So this is why we have to consider the radio interferences in the power system, both subjected to the low frequency and high frequency. Then coming to that, the measurement of the radio interferences, the noise generated in the radio frequency band. So as a result of the corona or partial discharges in the high voltage power apparatus may be measured by using the two different method. That is, first one by the radio frequency line to the ground voltage. This is known as radio influence voltage or RIV. And another one we have as an interfacing field by the means of an antenna known as radiated radio interference voltage, or generally it is RI. So normally the test and the measurement which is done in the laboratory are RIV measurement, where field investigations with the portable radio receivers are RI measurement. So this is the schematic representation of the circuit diagram measurement for RIV of the high voltage operators in 150 kilohertz to 30 megahertz frequency range. So in the radio noise meter, which is used in the laboratory, which is consists of a portable radio receiver with a local oscillator, a radio frequency amplifier, and the mixer and intermediate frequency amplifier detectors. Okay, the frequency range of 150 to 150 kilohertz to 300 megahertz range of the frequency. In addition to this, radio noise meter has multiple input circuits to accommodate the number of the pickup devices, attenuators, calibrators, and output circuit consisting of the special detectors and the meters. So generally the detector circuit is consisting of diode detectors, which is in series with uh, the circuit RS value. Okay, um, the which is in charging parallel to the RC network. The detector which is provided with a measurement devices to measure either the average value or the peak value or the quasi peak value. The voltmeter provided at the end of the detector has an input impedance of around a 50 ohm to 75 ohm. Then the test circuit for the measurement, which is shown here, the schematic diagram which is going to be shown here. The RIV meter is first calibrated as per the standards. The important components of the circuits are, there are the three things, is the radio frequency choke to limit the loss of the RIV voltage and to conduct energy from the sample. The choke itself has free from the noise and having the impedance should be less than 1500 ohm, and the coupling capacitor is of less than 0.001 picofarad, and it should be free from the noise in the operating range, and the resistance R should be equal to 800 ohm. The value which is indicated by the meter which gives rise to an conducted radio noise from the test sample. Then the coaxial cable having the characteristic impedance of 185 ohm shall be connected between the resistors R and the radio noise meter. So when there is an radio noise meter measurement are stated, the information regarding the specification of the meter which is used, the frequency range of the meters, the band pass characteristics and the open circuit and the detector characteristics have to be mentioned in the circuit. Nowadays we have a transmit system above of 765 kV above. So the radio noise voltages are the importance, and corrective measures have to be adopted for various operators and hardware to minimize the radio and television band noises.